Derivatives of general exponential and logarithmic functions. I've just skipped through the first part of the page to get down to the bottom part where we're differentiating implicitly with respect to x. So we have the function b to the power of y equals x. I want to take the derivative of y with respect to x. Derivative of b to the y is b to the y, the ln of the base b, and the derivative of whatever y is with respect to x, and the derivative of x is 1. I'm going to rearrange to isolate the derivative of y with respect to x, and I'm going to end up with 1 over b to the y ln b, and therefore I can summarize that the derivative of y with respect to x is just 1 over x ln b. So let's see what this looks like in some examples. Okay, question 1. Y equals 3 to the power of x squared plus 2. The derivative of y with respect to x. Well, first I'm still going to have my exponent. Then I'm going to have ln of the base of my exponent. And then I'm going to have the derivative of the exponent, which is 2x. Rearrange this just so that it is kind of appearing in a more expected order. And I'm complete. Here I have a quotient rule. The derivative of y with respect to x. First, I'm going to take the derivative of the top. The derivative of an exponent is the exponent itself, the ln of the base, and the derivative of the exponent. Then the bottom function. Subtract, keep the first, and then take the derivative of the bottom, all over the bottom squared. Okay, I'm going to look for like terms here. I've got a 2 and an x and a 2x. So I'm going to bring out 2x, which is going to leave 5 to the exponent 2x plus 1, ln of 5, and one more x, minus 5, 2x plus 1, and I took out that 2x, all over x to the 4. I've ended up with another common factor. Now I have 2x, 5, 2x plus 1, x ln x minus 1, all over x to the 4. Okay, let's try this guy, the log. Now it doesn't give me a base, so I'm going to assume that the base is 10. And the derivative of this is going to be 1 over the argument, 5x squared minus 7x, and the ln of the base, just following the rule. On top, I'll have the derivative of the argument here, so 10x minus 7. Final one, a bunch of stuff going on here, but take it one thing at a time. I've got the chain rule, and I've got a log. Okay, so derivative of the first is 3x squared. Keep the second. Plus, keep the first. And derivative of the second. So I have a log, so that means I'm going to take the argument as it is, and ln of the base. And then I'm going to have the derivative of the argument. So that is bring down the half, and whoops, I don't want that. Reduce the exponent by 1, and also take the derivative of what's on the inside there. Okay, next step, clean this up a little bit. This first bit doesn't really change. Let's look at see what we've got here. The next bit, I see a 1/2 that I can get rid of with a 2. I see an x squared, sorry, I see an x cubed and an x, so that's going to give me x to the 4. And I have negative root x squared over 4 and another negative x squared root x squared plus 4, excuse me. So these two are going to combine to make 1 x squared plus 4 and then ln of 2. Okay. I have an x squared and an x to the power of 4, so I can pull that out, which will leave me with 3 log 2 root x squared plus 4 plus x over x squared plus 4 ln 2. And that's a reasonable place to leave it. I can also bring out this root sign if I wanted and bring it out and have it be 1/2. I could do that if it seemed necessary. So that would give me 3/2 log 2 x squared plus 4 plus x over x squared plus 4 on 2. Okay, the homework is a handout. Let me know if you have any questions.